Hey guys, welcome to the YouTube channel, How to Math Stuff. My name is Seth, and today we're going to be doing a couple of direct proof problems. The first one we're going to start with is, it says let A, B, C, and D be integers. A, B, C, and D be integers. Alright, and then prove if A divides B and C divides D, then AC divides BD. Okay, so anytime we're going to do a proof, let's see, we can, before we try to write it up formally, we could say we know that B equals AX, where X comes from the set of integers. And we also know that D equals CY, or some Y, some element Y inside the integers. So what we need is to show that, we want to show BD is equal to AC Z, where Z is inside the integers, and some element in the integers. Okay, there we go. Sorry about that. I realized our paper went off screen. Okay, so this is what we need to show. And this is what we have to work with. So we want to show that BD is equal to AC times Z. So let's multiply it. Let's just take BD. What can we say about BD? Well, we know that B is AX, but we also know that, so we really, if we want to just expand it all the way out, we'd say, we could say BD is the same thing as AXD. But we also know something that D is equivalent to. So we could say AX CY. But wait a second. The set of integers has associativity, meaning that when we're multiplying terms together, we can rearrange them in any... No, associativity has to do with distributing with parentheses. Sorry, been a while. Commutativity. We can move our elements around whichever way we want, and it's the equivalent thing. So we wanted to show AC Z is equivalent to BD, because that would show that AC divides BD. So we could take this and we can rearrange those terms, and then we have AC XY. So this is what Z is. So then we could say let Z equal XY, and then AC XY is ACZ, which proves that AC divides BD. Now, I'm not going to bother to write up the formal proof. I just want to go ahead and do the scratch work and show the thought process, how to solve some of these proofs. So let's do another one. Okay, this one sounds kind of difficult, and I've never done it before, so let's try it. It is let A and B be integers. Okay, prove if A divides B, then AN divides BN for all N inside. Ah, dang it. Let's see. Okay, sorry about that. Okay, for all positive N. So we can't have a negative exponent for this to be true. But anything positive, this is true. And it would actually be the case for 0 too, because if you have a 0 for your exponent, then both of these would become 1 regardless of what element they are. And you could say 1 is equal to 1 times 1. So we could say this works for the positive, including 0. If we wanted to include 0 on it, we can. Well, let's see. So we're going to say we know for sure that, so we're going to assume B divides A. So B is equal to AX. X is in the integers. And we need to show that for every positive N. Yeah, so how does that look? How do we actually show that? Honestly, this seems way too easy, but so like, let's just look at some examples first. So this is really, A1, B1. What about A2, B2? So with A2, B2, we would have, it's literally just multiplying. Let's see. This is basically assuming what I'm trying to show. But, just bear with me here. Because I'm thinking, this is B equals AX, A, B. Okay. So if we just automatically did this way, then we're saying, at this point, it's like we're saying that A is equal to B, right? Because we know B is equal to AX for some X in the integers. But if we go down here and we're saying B squared equals A squared X, we factor out an A and we factor out a B, and we already know from up here that these are equivalent. So that's like BB. That would be BB, and you could divide out a B. Yeah, we would be saying that B and A was equivalent doing this. So we'd have to find some other integer. But why not just pick X? We could just say X to the N at that point, right? Yeah, let's say, okay, yeah, so we could say if we know that A divides B, then there's some integer X such that B is equal to A times X. Well, if we're raising A and B both to the N power, pick the element x to the n. We already know that x is the element that gets us what we need. Yeah, so if we took x to the n, then we have bn equals an xn I know I'm on the right track, but I feel like it's not technically right. Let's see. So yeah, we know b is ax. X is inside the integers. I know that x to the n is the element there. But how do we... Okay, I'm thinking. Hang on. Okay, we're going to go ahead and stop on this one. I think all we have to do is say b is equal to ax for x inside the integers. And I think we can say that for any n, raise b equals ax to the n power on both sides of the equation, and you have your answer. I'm pretty sure that proves it. Like I said, I've not been in college, not done any of this for a long time. So if I'm not right here, or if there's something I'm missing, let me know in the comments. I'd be glad to hear from you. And if you liked the video, while you're down there giving me your thoughts in the comments, please consider subscribing and liking and helping my channel grow. Thank you.